just so we know what we're going to do today, quick organization, because earth and ocean science is such a huge field covering from organic molecules to meteorites, even to science journalism here. I think we'll try to keep it pretty broad in scope and just not go too much into detail about specific questions about and specific presentations unless we get questions from the audience for that. So as an introduction, I think we'll start by a quick introduction and a general question. And for the introduction, I'll go around in the order you show up on my screen, and each one of you maybe will just state your name, which school you're at, the year of your grad degree, and your research focus, and maybe your favorite ice cream flavor. And then following that, just share something about how this year was for you. If, the lockdowns impacted your research, if you learned something about organizing yourself, or any kind of life lessons from this very crazy year. So Rebecca, you go first. Actually, I'll go first so I can give you an idea of what I'm expecting here. So my name is Adina Paitan. I'm from UC Santa Cruz. It's been about 25 years since I got my PhD, so I'm a pretty advanced professor in my career. Actually, I'm a research professor, and the focus of my research is global biogeochemical cycles. And my favorite ice cream flavor is rum raisins for sure. Now, about this year, one thing that I've learned is that when you stay and work from home, every day looks exactly like the other, and you really need to be intentional in taking breaks and doing other things to kind of impose some changes in your life. So I was very intentional and taking walk breaks every day. And one thing that I also learned is that I actually can do a lot of my work remotely. So because I live in Mountain View, and that's about an hour commute each way to Santa Cruz, even after we're allowed to go back to work, I'll probably at least 2-3 days a week will work remotely and lower our carbon footprints. So now, Rebecca, you go.
Awesome. Thank you. My name is Rebecca. I am a second-year master's student at San Francisco State University. Right now, I'm studying the risk of ship strike to humpback whales in San Francisco Bay. I'm very passionate about human-caused impacts to large whales, particularly shipping. My favorite flavor of ice cream is probably mint chocolate chip, or maybe death by chocolate. But I can't have that much ice cream because it makes my stomach hurt. And I think this year what I've learned is just to kind of be flexible, go with the flow. I think that makes for a good scientist and a good collaborator in general. I had to change my thesis about a year in, but it's ended up being, a lot better for me and more pragmatic in the long term. So I feel like I've learned a lot about ship strike. I've learned a lot about flexibility and positivity.
Cool. Let's go to Michael because he has to leave pretty shortly. So we'll give you a chance at least to introduce yourself.
Thank you. My name is Michael. I am a fifth-year PhD student at UC Davis. My research focus is, I guess, kind of broad, but I'm trying to understand the history that's recorded in the Earth's mantle, particularly with relation to volatiles. For example, one of the speeches was about, how atmospheres form or how they evolve over time in the study of exoplanets. That's something I'm very interested in, but I'm also interested in things like, say, the global carbon cycle. Because fortunately, these seemingly completely different questions or fields can be answered by the same rocks from the bottom of the ocean. My favorite ice cream flavor is anything with as many different kinds of chocolate. just pile it on. And my past year, oh boy. So we have, my wife and I have a 1-year-old child, which he's an utter joy. But for a while, it got pretty hairy in terms of the number of hours I was putting in. I was lucky, like 5 hours a week was a great week for me for a while. But luckily, I have a advisor who's also a parent and is understanding. So things worked out pretty well. And learn about organization. So yeah, I'm trying to prioritize, right? I'm trying, like, there's only 5 hours in the week now. No, exaggeration, but I'm trying to prioritize, like, order importance and to become more efficient in the work I produce. But that's it. Thank you.
Yeah, silver lining to everything. Okay. And Mick, bye, and enjoy the rest of the afternoon with your family.
Well, hi, my name is Mickey. I'm a 4th-year PhD candidate in geophysics at Stanford. And my research is on using machine learning tools to characterize the conditions beneath the Greenland and Antarctic ice sheets. My favorite ice cream flavor is pistachio. And during the pandemic, I've had to cancel research trips to Antarctica and Svalbard, which is in the Arctic. And that's been very sad. But the silver lining to all of that is that all of that time has allowed me to delve deeper into the machine learning aspects of my research. And in this winter, I ended up applying to a machine learning cluster hire at the University of Florida, and I'm thrilled to say that I will be starting a faculty position at the University of Florida this fall. So I think the pandemic has actually been a really big win for my research, and I'm looking forward to developing the Gator Glaciology Lab at Florida.
Wow, amazing. Congratulations. That's really nice. Hope.
Hi, I'm Hope. I am a 5th-year PhD student at the University of California, Santa Cruz. My research, I also study global biogeochemical cycles, which is just to say, I study organic chemistry and the carbon cycle in the ocean and how that interacts with biology and physical processes on longer term 1,000-year timescales. My favorite ice cream flavor would be anything with chocolate and peanut butter. And yeah, like everyone, this year was unique. I had to take a pretty substantial break from research because my 3rd chapter is all happening at Lawrence Livermore National Lab, and they were particularly strict about letting people back into the building, much more so than UCSC was. But I got to focus on writing up other projects, and am back doing lab work now, which is great.
Nice. Graham.
Hey everyone, I'm Graham. I am a 5th-year PhD candidate at UC Santa Cruz. I'm an isotope geochemist. I am a geochronologist. So I use radioactive isotopes to date things throughout the history of our solar system. So I spend kind of half my time using uranium decay and lead isotopes to date meteorites and how sort of the first chunks of rocks came together in our solar system. And then I also use the sort of early parts of the uranium decay chain, uranium and thorium isotopes, to study subglacial processes and how the bases of ice sheets are changing and how we can track those. I'm also a lover of mint chip ice cream, and yeah, the pandemic has been one of the I think like silver linings for me about this is it's given me a chance to really like revisit the way I teach and do outreach. I'm sure for many of us, when we started, we were, getting comfortable in classrooms and, learning these very much, boots on the ground, in-person tools. And it's been exciting and kind of inspiring for me to sort of recreate the approach I bring to teaching and outreach and finding new ways to do that.
Cool. Tyler.
All right, hello. My name's Tyler. I'm a fifth-year PhD candidate at UC Davis. My research is focused primarily on looking at crystal cargo in recently erupted volcanic deposits and using the composition and isotopic, both trace element and isotopic composition of those crystals trapped in those lavas to reconstruct sort of the rate at which magma chambers can move from periods of quiescence to periods of activity, as well as just kind of gaining a broader understanding of what magma chambers look like that feed volcanoes of different size and eruption characteristics. I would also say my favorite ice cream flavor is mint chip. We have a lot of mint chip lovers here, which is pretty awesome. And in terms of the pandemic, I would say that the best thing about it for me, if you can say there's a best thing about it, is that it's really allowed me to sort of refine a lot of skills that I was neglecting to do all my super time-consuming lab work. So I've been really spending most of my year writing all the papers I've been neglecting for the last 2 years, and also diving into refining some skills like coding that I've kind of let slip since I don't have anything else I can do right now. That's it.
Cool. And last but not least, Stephanie, and I saved you for the last person because I found what you're doing, what your presentation was quite interesting and unique because it's a little bit outside the box here.
Yeah, I'm not really sure why they put me in this group, but I'm happy to be here. So my name is Stephanie. I'm in the Science Communication program at UC Santa Cruz. Favorite ice cream is probably raspberry sorbet, which is not technically ice cream, but again, I shouldn't really be in this group anyways. And the timing of lockdown and quarantine was actually really good for me because I was finishing my dissertation at the University of Virginia, and so it actually got me out of lab long enough to be able to write my dissertation and get that submitted so I could graduate last May and then come out here to learn about science communication. So I am so grateful that I am not in the position all of you are in and trying to finish my PhD while not being able to get into my lab. So you guys are champs.
Cool. So now with that in mind, I have another question. And considering Stephanie's here and we all are focused or interested in publishing our research and communicating it to the general public, I would like you all to think about a pitch. You will pitch to Stephanie about the big picture of your work. How is the work you're doing now or the tools and skills you gained in your PhD or master's work, how would that be useful for society, for the future of our planet, for humanity, for something really important that Stephanie can write soon in her communication tasks as part of her research. So I can call you, or if anybody wants to go first, go ahead and do that. Okay, Graham, you start.
All right, put me on the spot. All right, Stephanie.
Just because I know you.
Yeah, no, it's good. It keeps me on my toes. Okay, well, I will keep this in the realm of the research that I sort of talked about here for ARC. So I'll leave the subglacial stuff to Mickey, and I'll talk about planetesimals. So it's we're sort of at this new frontier of starting to understand exoplanets, and trying to understand how solar systems come together and how planets are built. But where it's hard to do that. It's hard to see into another solar system. You don't need me to tell you that they're very far away. They're really hard to look at. And so the best thing we've got to study with a fine-tooth comb is our own solar system. And so if we want to think about how planets are forming, how we make things like Earth, we have to actually look back in time to 4.5 billion years ago when our solar system was first coming together. And in order to understand the rates and the processes that are bringing these planets together, we need chronometers. We need timekeepers. And there's nothing better for that, and nothing so long-lived for that as radioisotopes. And so we can use those, and if we can couple those to models that keep track of process, then we can start to relate just isotopic data, a bunch of ratios coming out of a rock to an actual process. And so I think a really exciting field of cosmochemistry right now is refining our cosmochemistry chronometers, our timepieces. And so there's all sorts of cool and kind of boutique things out there using these extinct radioisotopes that were created in supernova. And those are awesome and really useful, but there's this classic Earth chronometer, the uranium lead system, that still has a lot of utility for tracking time and cooling processes. And so that's what I work in. I think a lot of folks are doing, there was a big surge of uranium lead work in the 70s and 80s and 60s when folks were really starting to find the use of this tool. And I guess I'm taking more of a retro approach to this, but I think there's a lot to be done with it, looking at the cooling rates of certain meteorites.
Cool.
Sorry, I've talked long enough.
No, that's good. I would say Graham's keeping time of processes on this, or on the Earth and other solar system bodies. So that's very cool, and hope you go.
So as I mentioned briefly earlier, I study the long-term carbon cycle in the ocean, specifically organic carbon. And as most of us know, humans are outputting a lot of carbon into the atmosphere. And of those emissions, about a quarter of them are ending up in the ocean. And once there, they kind of have these carbon molecules have two potential trajectories. Generally speaking, carbon dioxide will be utilized for photosynthesis, turned into organic molecules, and then they can either enter this short-term cycle and probably go back into the atmosphere eventually, or enter this long-term cycle where they're stored in the ocean for thousands of years, which means they're sequestered from the atmosphere on human timescales and timescales of climate that we're thinking about when we're thinking about climate change right now. But what determines whether a molecule enters that long-term cycle or the short-term cycle is still really not very well understood. And so my work aims to try to understand why some molecules are persisting in the ocean for as long as they are, and how this pool of old carbon is going to respond to this continuously growing influx of carbon. There's about as much carbon in the ocean in these organic molecules as there is all the carbon in our atmosphere as CO2. So if 1% of that pool started to get utilized by organisms faster than it is right now, it would be equivalent to all of the anthropogenic carbon dioxide emissions over the span of 1 year.
Fantastic. So some nature-based solution for climate in the long run. Fantastic. Okay, Mickey.
Well, Stephanie, my research addresses the question, is the West Antarctic ice sheet on the brink of collapse, or is it not? And in order to be able to answer that question, we need to know what the ice sheet is sitting on. What's the topography, and the geology and hydrology, because those are the parameters that we need to be able to model ice sheet flow. The problem is that all of those conditions are under several miles of ice, and the ice sheet is really, really big. So they're very difficult to measure, especially at large scales. And for that reason, we really don't have a good picture of what they are, and there's wild uncertainties in our sea level rise projections. So I'm developing the tools that enable us to characterize this environment with much greater levels of accuracy.
Cool. So we have carbon sequestration, sea level, and timekeeping. And Tyler, how about you?
Okay. Yeah, so my research has a really nice link to society in that I am attempting to sort of constrain the time scale over which a magmatic system can go from sort of these long-term storage as sort of steady state, not really doing a lot of things that are geologically interesting or societally interesting, to how rapidly can they move into something that can erupt. Sort of over the course of volcano science, we used to think that things were sort of at steady state for hundreds of thousands of years, and then they just kind of preferentially burped up magma or lava. But over the last 20 years, the community has really shifted towards thinking that magma chambers are stored as sort of really cool slushies that are essentially remobilized on potentially as short as months to decadal timescales, which are very important because that overlaps with sort of active human timescales. And so my research sort of throws a lot of chronometers at volcanic crystals to sort of quantify how rapidly that can happen in systems of different size and eruptive style. Yeah.
Wonderful. So we also have geohazards, which is also very much important to humanity. And Rebecca, I left you to the end because it's always fascinating to talk about charismatic megafauna. So you are the poster child for any type of nature cover page. So go ahead.
Yeah. So I would just say that, as climate change is altering the distribution of species in the ocean, like, even food species like krill and anchovies, it's also altering the distribution of those larger whales in the ocean, and therefore moving them closer inshore and increasing their overlap with human impacts like shipping and fishing. So we, and not just in here, but in other areas as well, such as Boston Harbor and Puget Sound, we're getting whales closer to shore. So this means that our old management strategies, our old way of looking at things is no longer sufficient and is no longer reflected on the distribution of whales and other species. So particularly here in San Francisco Bay, we didn't have humpback whales east of the Golden Gate Bridge until about 5 years ago. So nobody has ever studied this. Nobody's ever looked into the degree of overlap between shipping or fishing in the area because it's brand new. It's a new frontier. So it's really important to be able to look more thoroughly into those levels of overlap, the speed at which vessels are going, areas of priority for management, so that we can kind of update our current strategies in order to protect the whales that we share the water with now.
Cool. So Stephanie, do you have any kind of suggestions or comments to any of the students here who proposed some things for you to write about or advice?
Yeah. Oh, well, I mean, everyone did a great job, especially being put on the spot. Um, I thought a lot of you, and I tried to take notes, but I think almost every one of you, first of all, again, good job. We're all on the spot. I didn't know I would be grading you. Something as a science, so I guess what I'll say is, as a science journalist who talks to scientists, the things that we love is when you use metaphors. Sometimes we try to come up with metaphors and sometimes they suck because we don't understand your science as well as you do. So sometimes scientists will read our stuff and they'll be like, oh, that's not how it works. So always, if you have a metaphor that you really like, give us your metaphors, and we would way rather use yours than our own. So I think a lot of people use really kind of colorful, like Tyler's, calling them magma chambers, comparing them to slushies. Like I would 100% quote that in an article. That's just really rich language that like journalists love. Graham talking about the timekeepers, which is just such a lovely way to talk about something. When you say radioisotopes, people are like, oh, I don't know. That's like a lot of things from 7th grade chemistry that I should remember and I don't. But by making it, assigning it this role, which like they are timekeepers, we use them to tell, you know, geological time. But I thought that was really cool. Something a lot of you did that again makes my job easier is saying where is like kind of where's the knowledge gap. So all of you set up like this is what we knew and this is what we don't know. And so I'm working to answer this question. And so that really helps us kind of frame our stories so we're not, you know, just writing, you tell us all the background and we're like, oh, that's really cool. And the story is about the background, not about what you're doing now. If we don't understand why what you're doing is like an urgent problem, or, you know, we didn't have the technology to answer it before, or like Rebecca said, shipping and fishing and hitting whales with boats has not always been a problem. Like it's only a recent problem, so no one was studying it until it started becoming a problem. So yeah, no, I thought you all did a really good job. Just watch, and again, I know all of you understand each other better than I do as the immunologist journalist, but just it helps if you have friends, like if you're ever going to practice doing an interview or practice talking to like a public audience, go over things with like a partner or a family member or a friend who's not in your field, because people catch me in this all the time. They'll all talk about something, they say, oh, I don't know what that means, that's jargon. I'm like, what? That's not jargon, everyone says that. And so a lot of you, I could tell you were using simpler words, which was awesome, but there were still a few things where I was like, nope, that word that you think isn't jargon is still jargon.
Yep,
So
that is a really good advice. So we don't have a lot of time left, but I do have one last question to ask everybody. And again, it's not something that you may have thought about, but that's an opportunity to think about that. And that is kind of maybe close your eyes for a second and imagine where you see yourself in about 5 or 10 years. What will you be doing? What will you be studying? Maybe where do you see yourself working? And maybe if you don't mind, share that, and we'll all wish you that that's where you will end up being and doing. And now I guess Tyler will go first.
All right. Well, it's something I'm thinking about a lot now, given that I need to graduate here in the next year. But I think ideally I would like to end up at one of the Cascade, or not one of the Cascade volcano observatories, but one of the volcano observatories. I'm really interested in applying what I'm doing now to more sort of field-based volcano science, sort of like real-time monitoring. So ideally working at some sort of volcano observatory would be the dream.
Cool. Graham?
That's a great question. So I'm actually finishing up at the end of this summer, and I'm starting a postdoc doing data science and meteoritics. And so, yeah, I guess in looking further out to the future, I'm excited to, find ways to build on like data science techniques and sort of integrating those more with meteoritics, as well as thinking about those more in terms of climate and younger paleoclimate processes as well.
And Mickey, I know you already got a position, but we're talking 10 years down the road. Maybe you might want to do something different, or how do you see your position turning out?
Well, I see myself being at the University of Florida 5-10 years more than that from now. I'm really excited. I'll be running the Gator Glaciology group, which I named last week. And I will continue doing machine learning related research on cryosphere problems and continue building on my work to study conditions beneath the ice and link this to sea level rise predictions and ice sheet dynamics.
And you will like go to expeditions in Antarctica and it's very well.
Yep, I'm going to the Arctic next year. We're going back into the field. I'm excited.
Hope.
Yeah, echo others. That's a great question. I see myself continuing environmental research. I really miss lab work and I envision that being a part of my career, whatever that ends up being. Also finishing up my PhD soon and applying to some postdocs at federal research institutions, which would be an appealing career track if that works out. But so something along those lines.
Nice. And Rebecca, I think you're still a master's student, so maybe let's see what your plans are.
Yeah, I'm quite a bit behind the rest of you, I think, but I guess, you know, I'm graduating in December, so sometime after that, I want to just kind of find a way to continue some of the projects we've started here, because like I said, I'm just really excited about just the fact that this is a new phenomenon and it, you know, the whales in the bay, and it hasn't really been thoroughly studied. So I'd like to spend some time doing that, and then eventually I think I want to kind of do what you guys are doing and go for a PhD. I really want to spend my life studying human impacts to whale species, maybe in the future, something more rare, a lesser known species, and lots of field work, I hope.
Well, one of the presenters before talked about personalities of fish. I mean, whales are mammals, for sure they have personalities. It would be quite interesting to see if certain whales are more likely to be crazy adventurous and go butt heading with ships, or others are more shy and shy away. So kind of related. And Stephanie, what will you be in 5-10 years?
The choice I am currently making is if I want primarily to be writing words for people to read or writing words for people to watch. I have kind of fallen in love with video production during my program here and have a pretty hefty background in theater. And so right now, ideally, I would be either writing science history, like biopics for the stage, or screenplays, and or making science documentaries and following you guys into volcanoes in Antarctica and making films about that.
Cool, and hopefully you can also include some community participation in these aspects, because that's something that all of us as scientists have to consider and think about, because you know, what we're doing is relevant to society. We're getting funded by society and taxpayers, so it's our obligation to keep that in mind as well. And with that, I think all of us should thank the ARCS Foundation for this honor. And I was already getting texts that we have to finish in a minute. So I'll just say goodbye, and I wish you all luck in your future careers. And I do have one last challenge for you, which I would not put you on the spot for answering, but it would be really fun if you think about it. And if you want, send me an email or send each other an email about that. Think of a proposal that all of you can collaborate on. So put all your forces together, all your skills and talents, and write a collaborative proposal with all this group over here. I think you can do it. It won't be necessarily simple, but that's a challenge that if you can come up with a solution, it doesn't look so far what you're doing, you know, so remote or desperate, that could be done. And that would be really a fun exercise. I would love to read that proposal. So think about that. And with that, I think we'll all say goodbye and good luck.